lens would you place a converging lens of focal length 9 centimeter so that image of both the sources are formed at same point. This is the question to say. Yeah. Try this question. Image of both the sources is formed at same point. So remember this thing. And so try to locate the position of the object first and then solve this question. Yes. Anyone getting any answer? You need any hint? Did we discuss this question, beta? Yes. Okay. See what they are saying in this question that there are 2 point sources of light at 24 centimeter separation, and there is a converging lens. Say the surrounding medium is rarer, then of course convex lens and its focal length is 9 centimeter, and the image of both the sources is formed at the same point. Now we know that if both the sources are on the same side of the lens and they are not at the same point, there's a separation between the two, then the image cannot coincide, because as the object moves towards the lens, image moves away from the lens, right? So clearly the images cannot coincide. This can only happen if the objects are placed on two different sides of the lens, because then for one the image form will be real, and for other one the image form will be virtual. The focal length is given to be 9 centimeter, and separation between the two is 24 centimeters. So clearly for one the distance will be less than 9, because for which the virtual image will be formed. Another one will be less more than remaining two. Okay. So this is the position of first object, and here is my second object. Say the distance of first object from the optical center is x, then of the second object from the optical center will be given as 24 minus x, because it is given that O1 and O2 are at a distance of 24. And image, since we know that I'm taking, say, O1 is the case where the distance is less than 9 centimeter, or it is between focus and optical center. So clearly the image is, for this O1, the virtual image will be formed. So image will be formed somewhere behind O1. So say this is image,
and
how
this can we assume position, that it is lesser than 9?
Because that is the only case when the virtual image will be formed. What is in for what position of the object the virtual image will be formed? Right?
And why is it that one real and one virtual image must be formed?
Because otherwise the two cannot coincide. If we are having two objects placed on the same side of the lens, then as the object will move towards the lens, image will move away from the lens. If I draw a path of how the object and image moves, then it will be like this. Say this distance is f, this is 2f, here again f and 2f. So we know that when the object will move from infinity towards 2f, image will move from f to 2f in this direction.
Yes.
Right. Then when object moves from, say, 2f to f, the image moves from 2f to plus infinity, like this. So as the object is approaching the lens, image is moving away from the lens. And also then when the object is kept, is moving from focus to the optical center, like this. The image will move from this minus infinity to the optical center. In all the cases, we know that it is not possible that if we are keeping the object and image on the same side of the lens, the image can coincide. So, sorry, of two objects on the same side of the lens, image can coincide. Because if there is separation between the two objects, image will be also at two different positions. So only case possible is that if for one object image formed is virtual and for the other object image formed is real, then only it will happen that both are on the same side and can coincide. Got it?
Understood. Yes.
Okay. So say image is at a certain distance. U, या V ले लेते हैं. V here. ठीक है. So now can you solve it? Try to solve it for both the objects. You can individually form the equations using lens formula and solve what is value of V. We have to find out the position of, no, we have to find out the point sources. Distance between 2 points. So find out where would you place. So that means you have to find out the x and 24 minus x. Just solve it now.
आपके बात करने से अब एक और तरीके से आप मन कैसे आदमी तक तो जाओ
Ma'am, x12. Again, beta. Is the value of x 12? No, 12 won't. 12 means then the both will be 12, 12, na? That means you are saying the both are kept at the same place. No, it won't be the case.
Ma'am, I'm getting excess 18 centimeters.
Okay, you are getting 18 and other is 6 then.
Ma'am, ask me.
Okay, that is the answer. We get here 1 by f, that means 9, equals to 1 by v, that is minus v, minus 1 by u, that is minus x. This is my first equation. So I can say that 1 by v equals to 1 by x minus 1 by 9. And for O2, my object distance is minus 24 minus x. Image distance will be taken as v plus me, and focal length is plus 9. Using lens formula, we'll get 1 by 9 equals to 1 by v minus 1 upon minus 24 minus x. Okay.
Why minus? Isn't it 1 by v plus 1 by v?
No, beta, that is for mirror, na? We are using here lens formula. Lens formula is 1 by f equals to 1 by v minus 1 by v.
I copied it wrong.
So from here we get 1 by v equals to 1 by 9 minus 1 upon 24 minus x. Now you can equate these two equations to get your answer. Okay? Using 1 and 2, we'll get 1 by x minus 1 by 9 equals to 1 by 9 minus 1 upon 24 minus x. From here, x should come out to be 6 because h will be less than 9. No? You have chosen in this way. So I'll get here 1 by x plus 1 upon 24 minus x equals to 2 by 9. On solving, we'll get 24 minus x into x. ऊपर आ जाएगा 24 equals to 2 upon 9. ये solve it. कितना और x की value? So we get here 18 equals to equation बनेगा 42 के 24x minus x square, और equation becomes x square minus 24x plus 18 equals to 0. So it will be, is the equation correct? So solve it and you are getting x is 6 and 18. Roots of x are? Solve it.
Actually,
Yes, beta.
ma'am, can you also consider that O2 is between focus and optical center?
Yeah, but in that case, like the way I solve will not be applicable then, no? Because according to the calculation what I have done, I have taken O1 to be between this optical center and F. That's why I've taken the images formed on the side of O1. You can of course take O2 as like O2 as a virtual the object which is kept between focus and optical center, but in that case your image will be formed on the side of O2.
Ma'am, I don't understand why we took U as negative in O2 and V as positive.
You're not getting this thing because if I'm taking O2 as my object, then my incident ray direction will be this, no?
Right, ma'am.
And then from optical center to go to image, am I moving in the direction of incident ray?
Yes, ma'am.
So that means if I'm going in the direction of incident ray, to measure the distance will be taken as positive. That's it.
Got it, ma'am.
Yeah? Yes, sir. Is this question clear to everyone? How we approach this question?
Yes, ma'am.
Now write down displacement method or UV method. displacement method or UV method. We'll discuss this now.
Done.
Excuse me, ma'am.
Yes, Bacha.
Ma'am, how did we get 18 here?
You can solve this quadratic equation now. X square minus 24 plus 18 equals to 0. You will get two roots here, 6 and 18.
Yes, ma'am, but in the second last step, you got 18. Ma'am, how did you get that?
Okay, cross multiply.
That should be 108 now.
108.
Okay, 108. Sorry.
That gives the root 6 and 18.
Okay, I've not done the calculation, so. Okay, I never missed this one. Check it. Check.
Done.
Now, if we have a concave lens of say focal length f, and for an object kept in front of lens, we get its image, a real image, on the other side. Okay? So this is object, and so this is its image, real image. And say separation between the two is d. Object and its real image are separated by a distance d. So if distance between your object distance is say x, then image distance we can give in terms of the separation between the two, that is d minus x. Okay. So let's find out some relations between object and its real image, focal length, etc. Okay. So let's put the values of object distance, image distance, and focal length in lens formula. So for lens formula, that is 1 by f equals to 1 by v minus 1 by u. I'll put the values. Convex lens of focal length remains f only, that means positive. V here becomes d minus x and it will be taken as positive. Minus u here will be minus x because on the other side, okay? Because it's a real object. This is optical center. On solving it, we'll get here d minus x into x plus d minus x equals to 1 by f. So we get x square plus dx equals to df. Or I can write it as x square minus dx on the other side plus df equals to 0. This equation I'll get. Now we can see that it's a quadratic in x. Okay, so let's find out the root of this equation. So root for x will be given as d plus minus under the root of d square minus 4 df upon 2. Okay, so these are the this is the formula to find out the root of x, and for the root to be real, for real root, discriminant should be positive. That is d square minus 4 df should be greater than or equal to 0. So from here we get d should be greater than equal to 4f. So the minimum distance, the minimum value of d then.
Ma'am, shouldn't it be negative d in the formula?
Again, repeat better.
Ma'am, shouldn't it be negative d in the formula? Like
Okay,
x equal
x is equal to minus b. If it is ax square plus b, bx plus c, then it is given as minus b plus minus under the root of b square minus 4ac upon 2a. This is the formula. No? So like we actually have b as minus here. So minus becomes plus here.
Yes, ma'am, I forgot. Sorry.
Okay, so d is equal to 4f. So that means the minimum distance of between the object and its real image is 4f. So we can only get the real image if the object and the screen are kept at a distance greater than 4f. Okay. And also we can understand from there that minimum distance will be when the object is kept at 2f, its image will also be formed at 2f. This will be the closest distance. This is the position where the object and its real image will be closest to each other. At any other situation, the distance between the object and its real image will be more than 4f. Okay, is this point clear?
Could you repeat where it is minimum?
When the object is at 2f and its image is also formed at 2f. So this is the case when, this is the case for if u is at minus 2f, okay, yeah, 2 focal length. Okay.